Welcome to the Stormsurf video surf forecast for the week starting Sunday, October 7th. Looking at significant wave heights for the South Pacific Ocean, we see an area of windy conditions and 28-foot seas south of New Zealand. Nothing particularly inspiring. This is the third of a series of gales that have pushed under New Zealand, the previous two being stronger. We also see an area of 41-foot seas well outside the California swell window, targeting only South America. Let's get into the details. As usual, we'll start looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when they do form, help direct their track. We're looking for a trough, or that is a push in the southern branch of the jet. That's the most influential branch, not so much the northern branch. We're looking for that branch of the jet to push to the north. That would create a clockwise flow aloft and down at the surface. And of course, that flow is the hallmark of low pressure. Low pressure, of course, generates wind. Winds generate seas. Seas, as they radiate away from the fetch area to the north, generate swell. And swell, when it hits your beach, wherever that might be, produces surf. All right, now first off, you might say, why are we still looking at the southern hemisphere in October? Well, the short answer is nothing's really going on in the northern hemisphere yet. La Nina still in the atmosphere. The atmosphere still thinks it's summer, and so we're looking to the south appropriately to look for swell generation. All right, so looking at the jet stream, we see the ice line is, you can't see it here, but we'll just tell you, it's about at 65 south. So there's a little tiny gap between Antarctic ice, the Ross ice shelf right in here, and the jet stream, but there's no real trough and just minimal support for gale development. As we get into Monday, you see the jet continues, not particularly strong little patch here of 110 knot winds, lifting a little bit further north, and you see the jets falling south here over the southeast Pacific. That really shuts down any potential there, high pressure in this area. So the only window is like, let's say, New Zealand to about the central South Pacific. A little bit more of a trough tries to open up here, maybe supporting gale development into Tuesday. And more of the same into Wednesday. This almost looks like a trough trying to develop Wednesday night. And sure enough, yeah, a little bit of a trough Thursday maybe. But then we see a ridge. That is the jets coming from further south, just under Tasmania. And that will probably show, no, that ridge dissipates, but a new one builds right behind it on Friday. Still, this area right here is the main area, maybe to support gale development, but nothing particularly impressive. And then maybe Saturday, a better trough is forecast developing southeast of New Zealand, continuing east, sort of losing some of the winds pushing up into it as we get into Saturday night and Sunday. But oh, look at that. It's almost a semi-real trough as we get 180 hours out, but a big ridge starting to build under New Zealand behind that. So this is probably the last big focus for the summer. So let's take a look down at the surface. Surface level wind, surface level pressure. It's not the winds up 30,000 feet that generate a storm, though they help form it, but it's really that generate a swell. It's winds blowing on the ocean surface that matter the most. Right now, you see an area of 35 knot winds under New Zealand. That's not really what you need. You need at least 40, preferably 45 knot winds, and preferably more than that. We see that right here, 55 knot winds off the southern tip of South America, but that's outside of the California swell window and of no interest. We see winds building, there we go, 35 to almost 40 knots on Sunday night, and then fading to 30 knots and fading out. So probably not a whole lot going on there. Now we see 45 knot winds as we get into Wednesday. They're all aimed south into the ice sheet, of no interest there. You need fetch pushing to the north towards Hawaii or California if you want to get swell. Also notice this fetch here in the Tasman Sea as we get into Thursday. Certainly good for Fiji if it forms, and maybe some sideband swell pushing up towards Hawaii. That continues. Then we get into Friday. Small area 50 knot winds develop up to 55 knots under New Zealand on Friday. Now remember, there's a building trough in this area, so it makes sense that there is a gale developing or forecast to develop in that area. It continues off to the east, 50 knot winds into Friday night, then slowly starts fading into Saturday night down to 35 knot winds. Also, what's this? A little bit of a gale here, but notice it's falling southeast in the southeast Pacific on Saturday. Again, you really need fetch pointed to the north with the gale preferably tracking to the northeast to get swell. Broad gale in the trough here, but most of the fetch now as we get into Sunday pushing south into Antarctica, and that pretty much wraps it up for this immediate forecast cycle. All right, let's go take a look down at the ocean surface and see what effect these winds are going to have on the ocean. But before we do that, we're going to take a quick look because there has been previous activity in the southwest Pacific, all focused here under New Zealand because that's where this sort of persistent, I won't even call it a trough, but more of a just a zonal pattern has been. So on Monday, see a small area 32-foot seas passed under New Zealand, but it was the gale behind this was 35-foot seas that continue. Oh, there we go. Both of them sort of worked in tandem. We got up to 37-foot seas midday Monday and a broad elongated area of 30 to 34-foot seas. So that created one swell that's pushing sideband energy up towards Hawaii and also towards the U.S. West Coast. Arrival time expected for the U.S. West Coast, by the weekend, basically. Another gale pushes under New Zealand pushed under on Wednesday time frame. There you go. 32, maybe 34-foot seas in the California swell window. Continuing 35 feet into Wednesday night. Continuing into Thursday morning, then fading out. So there's a second pulse of swell from that, again, towards Hawaii and the U.S. West Coast. Nothing huge in size, but rideable surf. And then we move into where we are right now. This was actually Saturday. 29-foot seas, 29.9 feet to be exact, 29 feet. And then a little area 32-foot seas as we got into Saturday night. So this is much smaller fetch, not as high as seas, but still a third pulse of swell. And then here we are today. So the point being, looks like 3 small swells developed under New Zealand, pushing north and northeast. Probably good for, I don't know, probably almost a week's worth of surf into Hawaii and California. Nothing huge, but rideable waves nonetheless. And we'll take it as we wait for the North Pacific to come online. And then let's look out to the future. What's going on? Okay, here we are, 18C Sunday. That's good enough for now. Our gale under New Zealand fading out. And we're just going to roll through this because we didn't see any real fetch of interest until we got, there's the system in the Tasman Sea developing Thursday night into, whoops, actually, let's go take a look off here. No, this system off to the, in the far southeast Pacific, pretty much out of the swell window, nothing aimed north, no swell from that. Tasman Sea, yeah, what do you get? 26-foot seas, that's probably only good for Fiji. But this system, stronger systems develops Friday, due south of New Zealand with, I will say 39-foot seas, building to 42, almost 43 feet, and continuing into Friday night. That's, 5 days from now, and then fading slowly while lifting a little bit to the northeast. So if this were to develop relatively close to what's forecast, a decent pulse of swell could result for both Hawaii and California. So again, we'll take what we can get. Oh, and we'll just roll this out. There we go, out to the end of the week, and that is pretty much that. So let's take a quick look at the North Pacific. Now we see, little bits and pieces of energy, but nothing, not even 18-foot seas, so no swell, not even any wind swell really expected to result from any of this. But we do see something that catches our eye. This is Hurricane Sergio. And here's Sergio right here. You can see basically southwest of Southern California, about 1,200 nautical miles southwest, winds 85 knots. And the interesting part is by tomorrow morning, it's supposed to start recurving off to the northeast, and winds still in the 75, 70 knot range, then starting to accelerate and race to the northeast. But the good thing here is, I shouldn't say it's an issue, is it's basically just aimed due south of Southern California. So even though the winds aren't particularly high and it's not a particularly huge storm, just the travel direction alone should impart, and remember, winds in low pressure in the northern hemisphere are counterclockwise, so all the fetch on the north side of the storm is going to be aimed up towards this area right in here. So some decent swell should result. Now let's also be clear, swell should also work its way up into Northern California, just not as big as in Southern California. And you'll see that clearly. Let's just keep our eyes right here, sort of watch the directional arrows for where the swell is going, and you can see them starting to turn off to the northeast as we get into Monday. And there goes Sergio off to the northeast, right into central California on Friday. Swell in this area, we'll say mid to late week, all the way up into northern California. Not huge swell, but certainly rideable. The models now have typically been overhyping all these tropical systems, but nonetheless, you still get swell from them. Just take it with a grain of salt when you go looking, whatever site you're looking at. The tropical systems they don't produce as much swell as the models think they're going to. Okay, so that gets us to Friday. Now, what happens beyond there? Well, there is some suggestion. Here we go. Low pressure moving from the northern dateline region. This is almost a week out, Saturday night. And what do we have? 26, 27-foot seas over a tiny area, falling southeast, continuing south almost into the western Gulf on late Sunday, early Monday, a week out. If this were to develop as forecast, this might be... So Hawaii's already had a good pulse of swell from a system that pushed the dateline right around here. This one might actually give a legitimate pulse of swell for California and make it the first, we'll say, fall-winter swell of the season for the mainland. And certainly, swell also should radiate south towards Hawaii, but nothing huge again. Still, just rideable surf. One would have hoped this season would have started earlier, but it didn't. But not surprising given La Nina and given a current, other things that are going on in the atmosphere. And then wind swell. High pressure right now dominating the East Pacific, 1032 millibars, bumping up against the U.S. West Coast. Heat low inland, creating a pressure gradient. North winds at 30 knots as of right now. They were blowing stronger over Cape Mendocino earlier today, settling down, but generating large, raw, ugly wind swell into North California, down into Central California. You see Sergio, we'll pull it there on the chart. We're just trying to be able to see the date and timestamps up here as well. Anyway, we get into, and there comes Sergio into the picture on Monday. Wind swell continuing for Northern California. Also, fetch off the south side of this high targeting Hawaii. Maybe good for small wind, short period wind swell, like 8-second period, 7 seconds type stuff. Into the exposed east-facing shore on the Hawaiian Islands. That fetch continues into Monday night. Now, Tuesday, it starts pulling away from the islands a little bit. Fetch continues for extreme northern California, but notice a light wind pattern starts settling over central California up to almost Point Arena. So a mixture of wind swell, Sergio swell, pushing up towards the coast, and you see Sergio on the move, with the wind swell continuing for California, but not for Southern California. Sergio swell by Thursday should be hitting well into South California, North California. The wind swell fading out, and then the Sergio swell and Sergio itself gone as we get into Friday. The north wind swell pretty much fading out as we get to Saturday, but that's okay, because that's when the southern hemiswell starts hitting all of California, about 2 days ahead for Hawaii. So, wind swell, Sergio swell, and then southern hemiswell, and then as we get into Sunday, here comes the gale developing or supposedly moving into the western Gulf, if the models are correct. All right, let's take a look long-term, seeing what's going on with the MJO and possibly El Nino. As usual, we'll start looking at the equator in the Pacific, East Pacific here, West Pacific here, specifically the Kelvin wave generation area. That is the area, there's the date line right there, 5 degrees north and south of the equator from 170 west, so that's a bit west of Hawaii, and then on the equator, a whole way over to, there's New Guinea there, to 135 east, draw a box right in there, and that's where, if you get westerly anomalies in this area, and that's typically what happens during the active phase of the MJO, you can create Kelvin waves, and even without Kelvin wave, westerly winds in this area helps impart energy to the jet stream, and when the jet stream is energetic, that helps fuel storm development, and if you have storm development, you have surf. All right, so right now, actual winds, this is from the TAO buoy array, series of buoys strung across the equator, used for monitoring El Nino, suggests we're just looking at the arrows, east winds until you hit the date line, boom, and then actual, these aren't westerly anomalies, these are actual westerly winds in the far west Pacific. That certainly is a sign of the active phase of the MJO, or maybe, if it persists long enough, developing El Nino. Anomalies, differences from normal for this time of year. Winds are west over the entire equatorial region and stronger, not super strong, but strong in the Kelvin wave generation area. This certainly looks like some sort of westerly wind burst, some sort of active phase of the MJO, if not more than that. Pretty impressive. Let's go take a look at the forecast and get some past history, too, to see how this compares. So here we go, 850 millibar wind anomalies. Okay, so where's our Kelvin wave? There is New Guinea right there. There's Australia, the Philippines there, South America, Mexico, equator right there. The Galapagos would be there. Kelvin wave generation area starting right about here, 5 degrees north and south. So you draw a box right in there. So you see east anomalies in the far western Kelvin wave generation area, but westerly anomalies, these oranges and yellows, you just see the arrows coming from the west, filling the entire equatorial, central, and east Pacific. That was as of October 1st. You can just sort of put your eyeball down through here and see that pattern has been holding for about 5 days. Interesting. Okay, so zonal wind anomalies, we're going back to September. This is the whole planet on one chart. The date line is right down the middle of the chart, right there. Kelvin wave generation area, basically between these two tick marks, and so you go down, you see oranges and yellows, that means westerly anomalies. We're talking almost the entire month of September. Then we got strong westerly anomalies the last week and a half of September, and then strong westerly anomalies as we got into October, moving kind of out of the Kelvin wave generation area now, more over the entire eastern Pacific. And here's where we are today. Westerly anomalies outside the Kelvin wave generation area, east of it, and easterly anomalies. This is likely, just eyeballing it, the beginnings of the inactive phase of the MJO. So if the active phase of the MJO supports storm development, the inactive phase tends to stomp on it. And for the next week, those easterly anomalies are forecast filling the Kelvin wave generation area a week out. Not as strong as the westerly anomalies that preceded it, but still not what you want to see if you're expecting El Nino to develop. So let's go look at outgoing long wave radiation. So don't get excited by the oranges and yellows because they don't mean the same thing on this chart. Oranges and yellows mean more sunlight reflectivity off the ocean surface, meaning clear skies, meaning the inactive phase of the MJO. So per this model, the statistical model, suggests that the inactive phase of the MJO is supposed to be in play over the Kelvin wave generation area, which is right there, through about the next 10 days, and then fading. The dynamic model basically says the same thing. So we got about a week and a half of a situation not conducive to storm development as far as the MJO is concerned per these two models. Phase diagram charts, so assume you're looking down on the North Pole. The active and inactive phase of the MJO move from west to east around the chart like that, from the maritime continent, like Bali, that area, over the West Pacific, over the East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. Where the heavy dot is, that's where the active phase of the MJO is. So it's not in the Pacific, clearly. It is, probably over East Africa, trying to work its way into the Indian Ocean over the next couple of days. Just follow the green path. Each dot here is a day. Next 5 days, it's supposed to move into the Indian Ocean and then collapse there. That, per the ECMF model, GFS model, says basically the same thing. Upper level model, so the oranges and yellow on this chart, you can see there's South America, Mexico, New Guinea there, Philippines there. Oranges and yellows on this chart mean areas not favorable for precipitation. One would say the inactive phase of the MJO. You can see the inactive phase slowly working its way across the Pacific from now through till about the 27th of October. But we also see as we get to about the 22nd of October, the area supportive for precipitation, or the active phase of the MJO, moving into the West Pacific and making its trip across the Pacific into about mid-November. At that time, then some sort of very weak inactive phase is forecast setting up. So at this point in time, the charts generally are in sync. The CFS model now, 850 millibar winds. Okay, same deal. Kelvin wave generation area between these two tick marks. We just go down. You see the oranges and yellow. All that is westerly anomalies. That's either the active phase of the MJO, and it's like, my goodness, a continuous active phase of the MJO from July to October? Don't think so. That certainly is what looks like El Nino. And you can see the purple here. That's the low-pass filter. This contour suggests a generalized low-pressure bias in the center of the Kelvin wave generation area. That is typical of developing El Nino. So, and here's what's been happening since, let's say mid-September. Strong westerly anomalies. The solid contour line, is the active phase of the MJO. And then here you go. Here's today. You see in another 3 days, a very weak inactive phase of the MJO is forecast for this version of the model. Here's our easterly anomalies, these blues. There's the far west Pacific right there. So we got to suffer that. These are what? 1 week intervals. So about a week, 2 weeks, 2.5 weeks. And then the easterly anomalies start dropping out and westerly anomalies start redeveloping. Let's go one more chart. All right, so this chart's in reverse, but still, Kelvin wave generation area between these two tick marks. Just work your way right on up the chart. Yellows and oranges are westerly anomalies. You see, here's where we are right now. Here's our strong westerly anomalies now over the East Pacific. Let's overlay the MJO pattern. A little bit of a active phase of the MJO. Inactive phase of the MJO, the dotted contour is building here in the West Pacific, moving east from about today through about the end of October, according to this. But the interesting thing is, it doesn't matter whether you're active or inactive phase. It's the winds on the ocean surface that we're really concerned with. You see the yellows here developing about October 24th. Westerly anomalies start building in the Kelvin wave generation area, and as they start building, then the active phase, the MJO, sets up from, let's say, Halloween into about Thanksgiving. Very strong westerly anomalies forecast. This is like a westerly wind burst and continuing, but here's the date line moving right up there. So just barely in the Kelvin wave generation area as we get into December. That's normally the peak of El Nino, and basically what it's showing is not only westerly winds, but a westerly wind burst going nonstop from Halloween to Christmas and maybe a little bit beyond. If that doesn't juice up the jet stream, nothing will, especially in sync with moving from fall into winter. This would be a pretty prolific time for storm development if it were going to happen this coming fall and winter. All right, let's overlay the low-pass filter. And why is all that? Well, again, low-pass filter is a low-pressure bias in the Kelvin wave generation area. As we get deeper into fall, we go from 3 contour lines to 4 right there as we get into the December time frame. So December, January, probably early February, pretty ripe for storm development. Also notice this is so if this solid contour is low pressure, this is high pressure. And where's that? It's 60 west, so it's off the U.S. East Coast, but most of it is here. Where's this? This is in the center of the Indian Ocean. So we've been moving. This pattern is building. So this is like a La Nina things developing over the Indian Ocean. That should shut down storm development there. And the focus is going to become the Pacific, the central Pacific, around the Dateline region to maybe the western Gulf of Alaska as we move deeper into this coming winter. This is a much better pattern than what we've had for the past 2 years, where you've had this dotted contour in the Pacific, high pressure bias over the dateline. We're going to flip that exactly for this coming winter. The question is how much, how soon, and how strong will it be? Okay, and one other thing. So here is, right here, there's January 2018. Here is the strength of the active phase of the MJO. It's not saying where it is, just the strength. But what we're doing is comparing this to, let's say, last year, where there was one pulse of the active phase of the MJO, and that was basically it. The year before it, where there was a bunch of little things, but notice the peak of this one back in February. Pretty good, and the rest of these up to about 2.5 standard deviations away from the norm, where these are just low. So finally, we get into January 2015. This was the big super El Nino. We're not at that strength, but we're the best since then. And then we're going to even go back a couple years prior to that. Nothing, and nothing, and nothing. So if anything, just looking at this goes back to 2011. This looks like so far we're at the strongest pulses of the active phase of the MJO other than the Super El Nino in 2015. It's taking all that energy to try to shove La Nina out of the way, but that bodes well for this coming fall and winter. All right, so much about the MJO. Enough is enough. Let's get into what effect is it having on the ocean. We're going to start in the ocean, down ocean depth, West Pacific here, East Pacific here. These are the anchor lines on the TAO buoys that are strung on the equator across the Pacific, and the X's are the sensors on those anchor lines. They are giving us temperature information, and then we'll use a model to sort of guess at what are, how to fill the blanks in between. Looks like warm water in the west, 30 degrees, but it's been sitting at 160 to 165 east, but in the past 2 weeks it's moved to the date line. The 28-degree isotherm, which has been held at 160 west, is now moving off to 155 west. And the 24-degree isotherm line, which is back around 115 or so, is moving towards 100. It's about 108 or 103, sorry. 103, something like that, west. So it suggests that warm water in the west is moving east. Why would that happen? Well, if you got westerly anomalies blowing, that's going to push warm water off to the east. Let's look at depth, though, and look at anomalies, differences from normal for this time of year. What do we see? We see a large pool of 3 to 4 degree anomalies, basically filling the entire Pacific. It'll take warm water from here to get to here. This is like the date line to get to Ecuador, about 3 months to get there. So what this says is there's just a conveyor belt, a river of warm water flowing towards the Galapagos and Ecuador that will eventually erupt on the ocean surface here, then get caught by the trades and start blowing to the west. And when that happens, that starts imparting energy to the jet stream, and then the jet stream starts doing its thing, and all this are complete symptoms of El Nino. If you had cool water here, which we did earlier this year, and we'll go back and look at some history charts in a second. But that's all gone. That's a sign of La Nina. We don't see any sign of that. This is probably the last little pocket of La Nina. It's not even cool water. It's 1 degree above normal down to about normal. So there's warm water everywhere. In fact, here's another view of that. Different model, a little bit more higher resolution. We see a little pocket of cool water here under, near the Galapagos, Ecuador somewhere. That's the last of the upwelling phase of the Kelvin wave cycle. We see a mountain of warm water pushing off to the east. This is very good news. Here's the history chart we were talking about. This is upper ocean, upper 300 meters of the ocean, going back in time, West Pacific here, East Pacific here. You see cool water. This is a year ago, November 2017. In the East Pacific, that's symptomatic of La Nina. We've got a tiny little Kelvin wave. You can see warm water trying to push across under the equator. Didn't quite make it to Ecuador. And then upwelling, cool water. That's the upwelling phase of the Kelvin wave cycle. Then in February, large westerly wind bursts associated with a strong active phase of the MJO in the West Pacific. Took warm water, pushed it east. It kind of stalled a little bit, but then a second pulse came rolling in, and that pretty much ended any hopes of La Nina, but it didn't push us into El Nino. And then you can see right here, you can't hardly see it, but that's the upwelling phase of the Kelvin wave cycle right there. And here comes Kelvin wave number 2, looking significantly larger than Kelvin wave number 1 and pushing off to the east. We're probably about a month from it fully erupting, but even when it does start fully erupting, there's a lot. I mean, there's 2 months or more, 3 months of warm water back here behind that. So this suggests, and the models have been saying this too, that somewhere in the mid to late October time frame, water temperatures were going to head up dramatically. We've been kind of laughing at it, go, yeah, really, right? But sure enough, somehow this Kelvin wave in the mid-August, September time frame developed a lot stronger than it looked just by westerly winds and everything else, and it appears to be on its way. All right, so what's going on the ocean surface? All this, MJOs, subsurface temperatures, blah, blah, blah. You say, well, what's that got to do with anything? Because ultimately, the only thing that matters is warm water on the ocean surface. That starts supporting evaporation. That starts feeding energy to the jet stream. The jet stream, in turn, starts feeding the storm track. So where are we at? Well, pretty good news. Look at this. Warming water along Chile and Peru, building up along the Peruvian coast. Warm water appears to be erupting at the surface already from Ecuador over the Galapagos, the whole way out to, well, Hawaii's right there, Hawaii and beyond. And the even better news is warm water is building south now, almost filling from 10 south, and even more than that. This here, that was from one of the previous hurricanes, upwelling associated with that, not to be worried. No cool pockets, obvious, other than that little tiny pocket. But this area right in here has been plagued by cool pockets, and this sort of yin and yang battle between La Nina and El Nino. Looks like, at least at this moment, El Nino is getting the upper hand. Remember, westerly anomalies are blowing and are in control over this whole area. So trades are weaker than normal. That helps upwelling. That helps warm water build on the ocean surface. This is good news. The trend for the past 7 days, yes, we have a couple little pockets of cool water here. But look at this, warm water. This is the first time we've seen this couple years maybe. Warm water building along Peru, Chile. In the southern hemisphere now, this whole warm event to this point has just been isolated from the equator northward. There's hurricane tracks right there, upwelling. Sure, when you get 120-mile-an-hour winds blowing, that's going to cause a lot of mixing on the ocean surface, create some upwelling. Also from Leslie here off the Pacific, same deal. All right, but warming, at least for the past 7 days, south of the equator now. This is a good sign. And, of course, on the north side of the equator, other than these couple stray pockets here. The overview picture. Well, if we were in a real El Nino, you'd see this sort of giant triangle of warm water here. We don't see that right now. We see a generalized, modest warming trying to get going, but early stages. Now, we're in, October? Into the first week of October. Again, this El Nino, if it does develop, is by no stretch going to be some big, strong thing. It's going to be a minimal El Nino, minimal to modest at best. Okay, but that's better than La Nina. That helps storm development. We'll take it any way we can get it, right? And right now, that's about what we're looking like at this point in time. Sea surface temperature trends. Nino 1.2 region. This is the area around the Galapagos, Chile. Not really. You monitor it, but it's not an official sign of El Nino. But you want to see the trend doing like this, warming in this region. It speaks to the strength of El Nino and the eastward displacement of it. If temperatures aren't rising here, then it's hard to get a real El Nino. You end up with sort of a halfway El Nino, Modoki El Nino. Right now, temperatures half a degree, 0.501 above normal, but they were up to about 1.3 degrees above normal. And you see we're kind of getting this spiky upward-looking trend, where prior to that they've all been hanging right around half a degree below normal. So finally, in the Far East Pacific, it looks like La Nina is getting booted out. Now, the official Nino monitoring region, the 3.4 region, which is from 120 west to 170 west, 5 degrees north and south of the equator, you see, temperatures have been toggling about 0.3 degrees above normal, which isn't a whole lot. And now all of a sudden, boom, temperatures up to 3/4 of a degree above normal, 0.774. We'll see where this goes. But finally, between these two indices, we're kind of getting a sense that maybe El Nino's trying to organize. Let's hope that this current inactive phase of the MJO doesn't cut the legs out from under it. Is the atmosphere sensing that something's going on in the ocean? And is it responding to the warming surface temperatures over the equator? Well, not a whole lot. We were actually trying to get to Southern Oscillation Index, but apparently that's a site over, I think it's in New Zealand and or Australia, and it's down right now. But what it was suggesting is that the SOI for the past 30 days is negative. I think it was about minus 0.8, something like that, or minus 8, which is not super strongly indicative of El Nino. And for the longer trend beyond that, the 90-day average is, I think it was about 0.4, 0.5, something like that. So neutral, biased weekly towards El Nino. The more important one that we've been watching a lot and fretting a lot about is the ESPI index. It's the difference in precipitation between the area north of Darwin, Australia, and Tahiti. When the value is positive, that means that temperatures are warming here and you're getting more precipitation in this area. Of course, precipitation takes evaporation. Evaporation takes warm surface temperatures. The current index right now, 0.25. It's been sitting negative for 2 years. It's finally, it dipped down recently. It went positive, dipped down negative. Now it's back to positive, not strongly positive. But what we're hoping is if warm water keeps erupting in this area, this index will go up, and then that starts the whole chain of events that might lead us towards some sort of developing El Nino. And then finally, the forecast for sea surface temperatures in the Nino 3.4 region, the official El Nino monitoring region. October 1st, they were supposed to be about 0.75. We're not there yet. We're half a degree or something like that. But here's this persistently. This model and all the other models are saying this warming trend building into January, December, 1.3 degrees or 1.35 per the model now. That's actually up. It was down to just like 1 or 1.1 degrees last week. So the model is getting strongerly more in favor of El Nino and a little bit more strength associated with that, hanging on through till May or so and then dropping off, but still temperatures above normal, 0.75 degrees. All you need is 0.5 degrees for 5 or 6 months and you have El Nino. So this model is suggesting some sort of a moderate El Nino developing for this winter. So no real change. So for now, we continue to wait for La Nina. La Nina's gone, but it's still in the atmosphere. Again, it just won't give up its grip. We're waiting for that to happen. In the meantime, that's what's causing you go, where is fall? It's not here yet. It still feels like it's summer. The winds in Northern California, Central California, strong out of the north. It feels like it's springtime in California, and it sure looks like it from looking at the ocean. No storms going on, nothing happened. That's still this effect of El Nino, La Nina battling it out. But we think this is probably the last bit of the summer-like pattern fading out. At least we're hoping. That said, some small southern hemi swell is on the way. Swell from Sergio on the way for California. And then with a little bit of luck, maybe some swell finally starting to develop for the North Pacific as we get a week out. But that's a bit of a reach. Won't believe it till we get there. Watch the models. See it develop or dissipate for yourself, and we'll report on this again next week. See you then. Have a great week. Do it again next week. Same time, same channel.